Thank you so much. Well, thanks for being here. I want to talk about the evolution of Java and talk about a few things that has come together. So I want to wait for the screen to show up my screen. So in the past few years, we have seen a really good accelerated development of Java. And I'll be absolutely honest about it. I was that guy on the other side of the picket line constantly complaining that Java is not moving forward. I'm so glad to be proven wrong these days with the evolution of Java. More than 25, actually 28 years now, and the journey has been amazing in terms of where Java is moving these days. Well, if you remember back in time, we used to do object-oriented imperative style of programming in Java. Now, of course, we are able to do imperative, object-oriented, and functional style. So I used to say that Java 8 was the biggest change in Java. Well, of course, now there are some other exciting things. That's what I want to talk about today. Just to quickly mention a little bit, Java has type inference. We all know this. It was introduced in Java 10. But one of the things I want to spend a couple of minutes on before we go further is this important point, because there's a lot of fear in the minds of people in terms of how Java has been evolving. So let me emphasize this really quickly here. Java is being released on you could say, 6 months cycle. And I want to really emphasize this. Java is not, I would say, being developed on a 6-month cycle. This is extremely important to keep in mind, because something as important as a language, you can't rush into it. So one of the things that I really respect a lot from Java is that Java is truly agile. They're not pretending to be agile in the way that we believe in process, but they're really focusing on taking the time to develop things. So Java is not being developed on a 6-month cycle, but Java is being released on a 6-month cycle. So the reason they did this is something really important for us to appreciate, I think. And the reason is, back in time, they had this idea of releasing Java every 2 years or so. Nice theory. But one of the flaws they really got into was defining what would be in a release before any work got done. We as developers know how flawed that logic is. So when developers behind the Java language started implementing it, they would start adding features, and it's time to release, and they would go around and ask the developers, how are things going? And they said exactly what you and I tell our bosses: it's almost done. Well, it's almost done usually meant 7 years later. So they realized this is not a way to really build software. So they learned their lessons, but what is really important is they applied their learning. And so now Java is being released on a 6-month cycle. So when a feature is ready for release, it gets released. So there's no pressure on synchronizing things artificially. But also the releases are done through pre-releases. Everything that comes out in a pre-release for two releases, so there can be feedback also. What a great idea, isn't it? That is true agility as well. So one of the very first things that saw that light was type inference that was introduced in Java 10 for the local type variables. But I want to get into some really interesting features in the next about 40 minutes that we have to talk about what has been done in the past few years. Now, one of the cool things about Java is the evolution, but I want you to think about 2 words that I've been thinking about quite a bit: a statement versus expression. Now, we all use these things for a long time, but sometimes we may not realize the key differences at the programming language level. A statement, in my opinion, is really grim, because what does the statement do? It performs action. But a statement does not return any result back to you. How rude. So you call a statement, it says, I did some work, you want the result, you go get it yourself. So there's no return value from a statement. So what that really means is, by nature, a statement will result in mutation. So you have to cause side effect for any statement to be useful. And it really got me thinking. In functional programming, we avoid side effect. In functional programming, we try to program with immutability. And so it got me thinking, wait a minute, if a language is really functional or purely functional, then it shouldn't have any statements after all, because statements cause mutability. So a purely functional language is made up of expressions. And once I got that into my mind, I started really thinking more about expressions rather than about statements, even in languages that are not purely functional in nature. Now, that's what excites me about statements, like, for example, switch, that has evolved into an expression. But let's take a look at it really quickly here. Let's take a little example and play with it right here. Let's take a few numbers, if you don't mind. So let's start with a bunch of values here. So just some arbitrary numbers I want to start with. But what I want to do here is to perform a little operation of mapping. And I'll say I want to call a grade function, if you will. And then let's go ahead and output, let's say, for each. And let's say system.out_println. And we'll simply print it right here. So I want to write a grade function which doesn't exist right now. We'll take it in incremental steps, if you don't mind. So let's say I'm going to return a string for the grade. And let's say it's going to take as an argument a score I want to work with. And here I want to say return. Let's go ahead and say in this particular case, we will say I want to return in this case, let's say, we'll say a grade for score. And we'll simply output the score here, let's say is, and we'll provide a grade value after this. And let's go ahead and say a string grade is equal to, let's start with the worst grade you can think of. Let's start with a little f to begin with. So we have a little grade of f that we want to give, but how do I implement this code? So I'm sure we all have done this at some point in our life, right? So if the score is greater than or equal to 90, then we could say, in this case, a grade is equal to maybe a A. Then we could say, of course, otherwise, we could say, for example, once again, we could say something like if the score is greater than or equal to 80, we could set the grade to be equal to maybe a B in this case. And then, of course, if that's not the case, we could go with an else. And then, of course, we all can write code like that. It usually turns into a monster. How does that feel? Well, recently I came across a project for a client, and they had 169 levels of if and else statement. Code directly from hell, right? So I asked the developers, how do you maintain this code? And they said, we don't. And they usually find a victim to touch that code, and they kind of play a rock, paper, scissors, say it's your turn today to touch that code, right? So not a good idea. So of course, we would quickly look for ways to improve this code. So one thing we could do potentially is, if back in time we would use a switch statement, as you know. So we could say a score, in this case, we could say a math, for example, dot min, and a score divided by 10, 10, let's say. And in this case, we could say a case of, let's say a 10, we can say a grade is equal to an A. Maybe that's a good start. Then we could start with maybe a few more of these, and we can say, if the score case is a 9 versus maybe an 8 versus a 7, maybe in this particular case, and we could say in this case, maybe it's in this case, 6 maybe. And then, of course, we'll provide a little default value as well. And in this, we can specify maybe finally the grade value is going to be an F, maybe we'll assign it. So this is going to be an F, of course. This is going to be a C. Maybe we'll give a B here, and those two are A, and we could start with that. Now, of course, we could assign these grade values, and if you execute this particular code, what do you receive? Well, a horrible course after all. Every student fails in this class, isn't it? I actually once had a professor like that. You take the course only to fail. Not a good course, right? So what actually happened wrong? Well, statements, of course, perform mutation, but switch is very error prone. You probably noticed this already. You got to put that stupid break everywhere for this to work properly. Otherwise, it's error prone and could really fall through, and you got to fix that code. Now, that's the world we lived in once upon a time, but we don't have to do that anymore. So let's roll that back for a second. So what we can do is we can turn the switch into a nice expression. So we can assign the value of a switch to a variable or even return from it in a function if we wanted to. So as a result, what we can do here is, now one way you can quickly know if it's an expression or a statement is that you're going to have a semicolon at the very end of this. So essentially, in this case, I can change that to a little expression. So as you can see right here, we can simply put a little arrow, nothing to do with lambdas after all. And then, of course, we can also shorten it a lot more concise, as you can see in here, than what we had before. So as a result, the code becomes a lot more easier to write, and it doesn't have an automatic fall through, so that becomes a lot easier to work with as well. So that becomes a nice switch expression we could use rather than using a statement. We can also combine things to remove redundancy in this case. So we can put multiple cases right there, multiple labels as well, and we can combine them together. What if you have a few more lines of code to write? You can certainly write them as well. For example, in this particular case, you can say, if it was a C, maybe we should do some kind of auditing. You could say, audit, for example, and then, of course, you can come back here and yield the result of that as well to the caller. In this particular case, it does require you to spell it correctly, though. So as a result, you can see that it can put multiple lines of code as well if you really wanted to. So that gives us an idea about how not only the code can become more concise and expressive, but less error prone as well. And of course, because it's an expression, you don't have to mutate things, and you are able to really program with more immutability or things that don't really change once you create them. That makes it for safer programming and can create pure functions as well more easily. So that's your switch expression. So of course, a switch expression has been evolving over time, and eventually it's blossomed into a pattern matching syntax, but I'll come back to that later on and talk about how that works. But let's switch gears a little bit and talk about something else a little bit here about what they have done as well. So let's take an example of a process, let's say. Just take a little example of sending a value. And here, let me say I want to send a little string as well, in addition to that little number I'm going to pass in. Maybe this is going to process some messages that flow in to the system. So I want to say I want to return a process is going to take a message of some sort. But in this case, my message, I could say a message is an instance of an integer. So we'll start with a little bit of a if-else again. So in this case, we can say a return, let's say, got a number. We'll just start with that. Otherwise, we'll simply say return, we'll say whatever. I don't care about that right now, just yet at the moment. Now, of course, I want to know if it's a string. So I can say a message is an instance of a string. And what am I going to do here? I'm going to say return got a string. Well, that's a good start, so we can display got a string. But I want to say of length, and I'm going to say plus length right there. Oh, what is a length, by the way? So we could say length is equal to a message, let's say, dot length, and get the length of that. Question to you, will that work? No, of course not. You know this as Java programmers, right? Because when you try to run that code, Java tells you message.length, length variable, message of type object doesn't have a length. So what you have to do is to do the following, right? You take the message, and you have to really ask that particular reference to be, you got to twist that a little bit and execute this code, and it works. So of course we know this concept. They call this, anyone remembers what it's called? That's right, they call it casting. I call it punishment. So essentially, think about this for a minute. Imagine you are leaving work one day, and as you are leaving the evening, you see one of your colleagues, and they're happily running out, and you said, hey, where are you going? And they say, I'm going to watch that movie I've been postponing for a long time. And you say, well, have a great time. Well, the next morning, you see them at breakfast, and you ask them, did you go to the movie? They say, yes, I did. And you say, how was it? And they ask you, how was what? You're going to stare at them and say, really? And you're going to roll your eyes and walk away, right? Now, you're not going to be friend with them for a long time. Look at what Java did. Hey, Java, is that a string? Oh, yes, it is. What's the length of what? So you ask the question, do you, this kind of makes you wonder, right? Do you work for the compiler, or does the compiler work for you? Well, in this case, we've been working for the compiler. The compiler says, how's it going? You're like, I'm working hard. And the compiler says, not hard enough. I'll check back with you after lunch. So we've been writing all this code just to please the compiler. How terrible that is. Well, good news, we don't have to do that anymore. You can simply go back to this code and say stir.length, where stir really becomes that reference you can create right there in your code. Now, I call this smart casting because languages like Groovy and Kotlin provide this feature of smart casting, but they call this with a slightly different name. They call this as pattern matching with instance of. Well, the reason they call it pattern matching with instance of is their destination was not this feature. It's more of an interim stop, if you will. So this is a nice byproduct, but they really wanted to introduce a feature so they could use this in pattern matching. We'll see this a little later on in this presentation where we can do pattern matching based on the types as well. And what you're going to see there is a nice syntax sugar, but this is exactly what's happening, is that it can perform the matching. So in here, what you need to realize is that literally you could say string stir is exactly the same as object message. Those two are really the same exact variable in memory. They are just of different type of reference pointing to the same variable in memory. The stir, of course, goes out of scope at the end of that block, and you cannot access it outside. So that's a feature that you can see nicely is the smart casting. But like I said, they call it pattern matching with instance of. Now, one of the other features that I really admire is a text block. But before we go into text blocks, this is also a nice lesson to learn about the true agility I talked about earlier. Well, in Java 12, they were supposed to release a feature of raw string, and about 3 weeks before the release of Java 12, that feature just disappeared. Well, that's really the beauty of this because the true agility relies on feedback-driven development. So they got feedback that it's not really working as intended for the longer purpose. They really wanted to create a multi-line string, and the raw string was a stopgap measure, but they didn't quite stand up to what their goals were. So they withdrew that feature, they reworked on it, and they released the text blocks. Now, I've used the feature of here docs in other languages. Don't get me wrong, this is an amazing feature in a lot of languages, but I've actually wasted quite a bit of my time in other languages because everything will work fine until it doesn't. And then you spend 15 minutes of your life just pleasing the environment to get things working properly, and then you're just tired and grumpy after that. Well, what I like about text blocks is they really did something very sensible. They thought about how we as developers would write code rather than how a compiler should deal with things. That's what I love about text blocks. But let's talk about what this is really with a little example. So let's say for a minute, let's say in this case, I'm going to say greet, and I want to send to this, let's say, a little text over here, and I want to see what this greet function can really provide for us in this particular example. So let's say, for example, we'll start with a little greet function, and we will say a string name we will say over here, but I want to start with return a message when we are done with that particular function. Now I want to say string message is equal to, and we could start with something. Let's say, for example, hello there, and I could even put a little string of the name, but we will put that later on. But then we are going to say a message plus equal to. I could say, for example, I would go ahead and stick that in here for a minute, and I could say, how are you? And I could even say, for example, something along the lines of it is, let's say I put a little great over here. and let's put up, escape again, seeing you. And then finally, let's go ahead and say, of course, how could I forget a little /n as well? And then finally, I could say, for example, let's say, thanks for coming. So essentially, we could write code like that to display some text. I'm sure everyone here has written code like that before. But the question is, would you put that on your resume? Would you say, I've got experience, 12 years experience using plus equals, right? This is the code you hide from humanity. This is not something you go tell your parents, look at the beautiful code I wrote, right? Anyone who works from home, that's all of us, right? Well, if you're working from home, if you're writing this code, and if one of your kids walk into the room, you got 10 seconds to close your lid. Otherwise, they look at this and say, that's what you do for a living, right? And this is not going to win the next generation of programmers. I really wish they told me this. I've got 2 boys who are all grown up today, and I cannot tell you how many times people ask me this question. So what they are programming in? And I sadly tell them, my children are not programmers. In fact, I am the last Subramaniam who will be a programmer for the next 7 generations. And I really wish people told me this. When my boy was a little small, I used to put him on my lap and I would be coding. And I wish they had warned me to say, don't do this, right? So he was sitting on the lap. He would be banging on the keyboard while I'm writing code. But one day, I just heard from him. He said, oh, and I said, oh my gosh, are you okay, kid? And he kind of looked at me and looked at the screen, looked at me and looked at the screen. I said, is everything okay? And then he said, Dad. And I said, yes. And he said, don't worry, I'll grow up and take care of you. You don't have to do these things anymore, right? So that's what happens when children see code like this when in front of you. So this is the code you hide from humanity, not something you want to write. Well, thankfully, you don't have to write that moving forward. So what you can do is you can instead use a multi-line string called a text block really nicely here. So you can see how we used a 3 double quotes right there. Get rid of all that junk that you see up there. So you can simply say, how are you? And you can even get rid of that stupid escape. You don't really need it. You can simply put the double quote directly in there as well. And then, of course, you can keep going with that. And you can put all the text you are interested in. And you got really good clarity on your hands right now. So you can just simply drop that code right there nicely. And you can just put all those text blocks right there as you would need. Now, what I really like about this is that they thought about this from the point of view of us, the programmers. So just to illustrate this point, let's go back here and say replace all. And I'm going to replace the space with a little tilde so we can see where the spaces are as well. So notice in this particular case, as you can see in this example, when I run this code, you can see that the H is starting exactly where the dash is starting. So what do we know about it? Well, the compiler very smartly, it's called a smart indentation, removed that indentation for you because the compiler knows you didn't really mean that. You really put that because the code requires indentation, not your text. Those are called smart indentation. So as a result, you can see the indentation went away automatically. But if you really wanted the indentation, you can provide indentations. In that case, notice the 3 little squigglies that you see here for those 3 spaces you added, because this is called the essential indentation, and before that is called the smart indentation or not real indentation. So it handles that very smartly. Now, a lot of times you are creating these documents to bring in an XML document or a JSON document. So how do you really do it? You typically do that by copying and pasting from a document, and then you start writing code, which typically means you're going to have all these spaces in the very end. And the worst first lowest point of programming is to sit and start removing those spaces. It's even worse. It's something you cannot see until you run the code because they are special characters or you have to twiddle with the IDE to see it. But notice the spaces are removed automatically for you, and that's another smartness baked into it. But if you say, oh my gosh, I really want that space, you can ask it to preserve that space as well, as you can see in that particular case. So it's a smart removal of spaces if you don't care about it, but if you do insist on it, you can keep them as well, as you can see. But of course, in this particular case, what is the end result of this, you may actually wonder. And that is the beauty of this, if you will. So let's go quickly take a look at this real quick here. If I say Java-C and compile this to bytecode and take a look at the bytecode that was created, what you notice up here is the fact that all that was purely a compiler feature. It's a load constant, and you have a string at the end of the day. So the point is, there's no feature of text block at the bytecode level. It's purely a compiler feature, and that as a result, you don't have any performance issues or you don't have any issues with runtime. It's purely a compile time feature, as you can see. So that's your text block feature. That's pretty darn good. And of course, one of the benefits of this is it's very fluent and easy to write the code with. But I got an email from somebody who's been programming in Java for about 20 years, and he said, this is not fair, and he was very angry. And an old guy like me, I would say, and I said, what are you upset about? He said, it's not fair, all the young programmers get to have all of this. When I was young, I didn't have any of these. Yeah, tough luck, right? So that's the beauty of it, that you can enjoy these features now, and for the next generation, it becomes a lot more elegant and effective and expressive as well. Talking about making things expressive, this is a feature I really like a lot, which is the feature of records. So let's take a look at an example of this. Let's say I want to put a location 1, and I want to display a location 2. We'll start with that for a minute. So I say location 1 is equal to new location. Let's go ahead and say minus 84.23, comma, let's say 131.456. I don't know where that is located, some federal prison probably somewhere. And then I want to put one more location. Let's even keep this to one more, let's say a location 3, where I'm going to change that value to some other number as well. Now, in this particular case, we have 3 locations I want to provide in here. But the question is, how do I implement this particular location class? Well, we have written this before, right? So you say location, and you could start out by saying a private, let's say a double lat, and you could say a double lon as well. You could write that right there. Now, once you write it, you can write a public location, and you could say a double lat and a double lon. And of course, within this, you could say this dot lat equal to lat, and this dot lon is equal to lon as well. Are we done yet? You say, no, you got to write a public double get lat to return the lat value. And then, of course, are we done yet? No, you have to write a get lon as well. And then, of course, at this point, you protest and say, that's not fair. I never do that, Venkat. You say, I only define the field. Then I gently right-click on the field, and the IDE vomits the rest of the code for me. Well, that's an IDE vomit we have to live with forever, isn't it? But even if you were to take all this effort to build this into your code, when you're done with this, unfortunately, it gives you that sad output, which is of no use or value for anybody, isn't it? So the question is, how can you remove all that boilerplated code? And the wrong answer is to use a library for it. Well, this should be really a natural feature in the language, so we don't have to write so much code. What if the language becomes more elegant? Well, it has, and that's the beauty of that. So we can go back to this code and get rid of all of that for us, and we can simply say, here is a location, and I want a lat value, and I want a lon value, but we also got something really going for us in addition to it. All the components, as they call it, well, they call it components. You may think of properties. are immutable. So that's the first thing about record, is that the properties are actually immutable. That's one thing you get as a benefit. Not only is that a benefit, of course, we're going to write that as a record in this case. And the records, all the properties are immutable. But here's the beauty. They offer a buy one, get 5 free offer. Who doesn't like that, right? Buy one, get 5 free, isn't that cool? Usually buy one, get one free is what I'm used to, but you got 5 things free. Like what? You got a constructor given to you automatically. So you have a constructor, which is nice. You also have a nice toString method. You can override it, but you see this already, those two. You got the constructor going right there and the toString available for you as well. You got the equals method available as well. And then, of course, you have the hash code method also available for you. So if you go back here and say location 1 equals, let's say in this case, location 2, and similarly, if I were to say location 1, for example, in this case, is equal to location 3, you can see that it says a true and a false, because these two have the same values, but this one doesn't. So the equals is implemented, and similarly, hash code is implemented as well. And then, of course, you also have the getter for the components are implemented for you automatically as well. Well, the records, of course, are immutable. You cannot modify the value once you create it. Of course, the immutability applies to the reference. You need to make sure that you do honor the immutability when you design the code. So for example, this is a good idea. String, you could say description is a good idea. But a string builder is a bad idea. Because a string builder is mutable, you don't want to do that, so be careful how you build it into it. So that is something you need to take care of and honor the immutability in your own design as well. So, of course, there's a lot more to talk about in records, but records minimize the boilerplate code, but records also are really awesome when it comes to the sheer expressiveness, but we'll see that a little bit later, how it really nicely flows with pattern matching as well. So that takes us to another feature I really like, which is the feature of sealed as well. Well, in order to appreciate the sealed, along with the records, let's do something a little different right here. So let's say for a minute, I want to go ahead and create a bunch of stuff here. We'll say cell is equal to new cell. And in this case, we'll say goog, and we will simply provide maybe a value of 1,000. And let's go ahead and say this is going to be a buy, and we'll call this one as a buy. And this is going to be a buy. Let's go ahead and buy AMZN, let's say of, a 500 here as well. But how do we model these is the question. So we will once again do a process right there, and then we will pass to the process function maybe a little cell, and maybe we'll pass to this a little buy as well. But the question is, what are those? Well, we can say interface a trade, and we can then say a record right there. And in this case, we can say a record called sell, which implements the trade, and a record called buy, which implements the trade as well. So we could say here is a ticker we can create, and then, of course, int quantity we can create as well. So quantity as a value, and likewise in the buy we'll create that as well. And then, of course, we can go ahead and write our process function right there. So we can say, for instance, we will say a string process, and within this we'll take a trade, and what are we going to do with this? Well, we can say a return switch, and this is where I'm bringing in the pattern matching syntax while we're going to deal with the sealed in a minute. We are not there yet. We'll come back to that. So I can say here, we could say a case of this is going to be a sell, and we could simply say, we'll simply say selling is what I want to return. and we could simply say buying, and we'll come back and improve on this a little bit later. So we can say default, and we will say, invalid trade. We'll just provide that for just a minute. So in this particular case, we want to provide that particular value of the sell and the buy, pardon me. So we can do that right there for this in here to display the selling, not setting, and the buying as well. So we can do that right there just as a starting point. But here's where the charm really comes in. Now, a sell and a buy are two candidates for a trade, but there could be potentially something else as well, but maybe you don't want that. You want to restrict what it can be. So you can say, in this case, a sealed interface, and they call it sealed classes, but it's a sealed thingy. It can be a sealed interface or a sealed class, and you can specify the members it can have. So permits a sell and a buy, those are the two things that we can really have. So if you say record here is let's call this as a fake trade, I want to create right there, which implements, in this case, let's say a trade. You cannot do this, obviously, and let's go ahead and say, in this case, string ticker. You will get an error at this particular point. You're not allowed to implement the sealed class. Why? Because the sealed can only have two members here, obviously, which is a sell and a buy. You're not allowed to have a third member. So this becomes really useful to create a hierarchy where you can control the members of a hierarchy. Let's think about the benefit of doing so. I've got a client who is building application where their customers can build plugins. But one of the requirements is that the people who are building the plugins can use their interfaces, but they're not allowed to extend their interfaces. There are some interfaces they can extend, some interfaces they're not allowed to extend. How do you tell the world these interfaces are for you to use, but not to extend? Well, the short answer is by writing a lot of extra code, which is error-prone, more effort, you got to spend more time testing. Well, sealed eliminates all that work for you. You can define your interface as sealed to convey to the world it's for them to use, but not for them to extend. This becomes really useful in systems where you want to have that kind of control. So this really gives us an opportunity to write a sealed class, and you can dictate what the members can be, and new members are not allowed in this particular case. Of course, one small detail here is records are already final. That's why I didn't have to put final in there when creating records which are sealed. That takes us to the pattern matching syntax I want to quickly talk about here. And we saw this already here, but here's the good news. I can get rid of the default right now, and the reason is because it's sealed, I don't need the default, because there can only be two members, and we took care of the two members. We can simply get rid of it. That's one of the benefits you get out of this as well. Now, in this particular case, the pattern matching is working off of the type, as you can see right there. So this is really using the pattern matching with instance of we saw earlier. So you can compare the type of the data. So this leads us towards data-oriented programming. So whereas polymorphism is very useful, there are times when that's not the right solution because you may not want to waste time building a parallel hierarchy. This becomes a lot more effective in processing data in systems where you got flow of data and you have to process different types of data. So that's really taking the switch into a pattern matching syntax. But where this really shines is with the destructuring capability. So for example, you can say selling, and you could say, for example, you want to say sell.ticker, and you can say plus, and then you could say, quantity. You could say, for example, in this case, a cell.quantity, and you can access it like that. Nothing wrong in doing that, but look at how noisy and redundant it is. After all, you really cared about the ticker and the quantity, not really the cell, so why not use destructuring? Well, construction or structuring is creating an object from properties. Destructuring is the opposite. You take an object, but you tear off the properties from the object. You're creating local variables that have values from the object. So you can go back to this code and say cell, and you can say string a ticker, comma, int q, just to emphasize it can be a different name as well. And you can simply say here is a ticker I got and the quantity that I got from that as well. And you can simply specify that as a destructuring as well. And that becomes a lot more effective in tearing apart the members. Now, obviously, in this case, you can also do a string, let's say, ticker, and an int quantity right there as well. And then you can say buying, and you could specify the ticker you want to buy and the quantity you want to buy as well. But maybe I don't care about the quantity, and I can simply specify it like this, and you are able to say buying Amazon, and you can print that as well. Now, that really takes us to the next little feature, which is one of my more recent favorite. And that is, when you look at this code, programmers often give really bad names for variables, especially when they don't care about those variables. I usually like to create better variable names. So in this case, I may insist on quantity for this, in which case I might go back here and say a quantity for the variable here as well as we create them. But on the other hand, if I were to maybe write this one, I might be tempted to use the word ignore to say that I'm not really using it. Well, yeah, that conveys that you're actually ignoring it. But if you give any other variable name, you are really asking people to read what is not really relevant, and that's not really fair. So this is where there is an international symbol for I don't care, and this symbol is called underscore. So you can simply replace this with underscore to say that you don't really care about it, and that really says that's an unnamed variable, meaning I don't care about it. So that is a newer feature you can actually use to say that that's a variable you don't care about. Just as an example, if you don't care about the ticker as well, in this particular case, you can replace the ticker and you can say selling, let's say in this case, quantity, and you can simply display the quantity as well. Or maybe you don't care about either one of them, in which case you don't have to write any of them at all. But just to emphasize, if you had 3 and you only want to get 2 of them, you could actually use that more than once as well in that particular code. I'm not suggesting doing it in this example, but just to illustrate that, you can see that you can actually use the underscore multiple times as well within an expression, if that were to make sense. Maybe you have 3 components, you don't care about 2 of them, you can use underscore for 2 and just use the last one as well. So that brings us to one other feature, which I will not go into detail here, but just to mention this amazing capability of virtual threads and coroutines and continuations. This is going to make a huge difference as time goes on in terms of scaling our applications as well. So in order to summarize what we talked about, Java has been evolving quite rapidly, but the growth has been really responsible, in my opinion, responsible growth rather than driven by infatuation or competition. So they ask 3 fundamental questions. They ask the question, is a feature really useful for Java programmers? Just because it's shiny doesn't mean we need to have it. Is it a feature that will make the life of Java programmers better? That's the first question they are asking. If the answer is yes to that question, the next question they ask is it feasible to implement it with a reasonable time and cost? Then the third question they are asking, if an answer to that question is a yes, is what impact will this feature have in future development of Java? Is it going to really make things harder to develop in the future if we were to add this feature? So they're very cautiously and responsibly evolving the language, which I'm really very respectful of for what they are doing. So the language is very power-packed right now, as we can see, and they're also looking at the future to see what kind of features to add. For example, you saw the pattern matching syntax with the destructuring. So the obvious question there is, why can't we destructure regular classes? Why just only records? And the answer only is because they haven't gotten to it yet. So they are working on, for example, providing a deconstructor, just like your constructor, to tear apart the object into these properties. So eventually you could start using destructuring on regular classes as well, not just records. Similarly, there's a lot of these different experimentation. They're working on string templates, for example, and so on, and a lot of features that are being tried in experimental phases in different projects like Project Loom, where the thread came from, virtual thread came from, Project Amber, and so on. And then they're releasing this as pre-releases to get feedback from developers, and then eventually growing that into the language. So if you're programming in Java as a young programmer, this is absolutely fantastic. For those of us who have been programming in Java for a long time, it is such a breath of fresh air to see the language we have all been using and loving is actually becoming much more elegant and nice and friendly and easier to use as well. So it's amazing in terms of what it can provide for us. I hope that was useful. Thank you so much for joining. Appreciate it.